Hi, we need to prove this identity, but because we haven't a proof as yet, we have to isolate one of the sides. And it's only fitting for us to do that. With the left-hand side, we're in the brackets, we can clear the brackets, simplify, and see a way to express the left-hand side as equivalent to the right-hand side. So clearing the brackets, we have 1 add sec A minus cosine A minus cosine A sec A. Now because we have a minus 1 here, I'm going to simplify sec A here and leave sec A here as it is. If I simplify sec A here, I wouldn't be able to actually simplify this because I'll just have 1 over cosine A. So the aim here is to eliminate this constant 1. Minus cosine A is minus cosine A, and sec A is a reciprocal of cosine A. So this cancels out to minus 1, all of this, and that cancels out that 1. And so we're left with sec A minus cosine A. Now the next thing we want to do is to write this now as a reciprocal cosine A minus cosine A. The reason for that is that we're always in maths, we're always trying to simplify things, and to prove something is really included in it, is to simplify steps as you go along to prove something. So sec A we write as in reciprocal of cosine A. And again we can simplify this as 1 minus cosine A, cosine squared A over cosine A. Now we know that sine squared A add cosine squared A is equal to 1. That's an identity that we'll use here. So we can write this now as sine squared A over cosine A. Remember we used sine squared A at cosine squared A is equal to, or is equivalent to, 1. So the identity that we used here. Further to this, sine squared A is the same as writing sine A times sine A. So instead of writing using brackets, we just write sine squared A. Just a shortened way of doing it without using brackets. So we can write this as sine A times sine A over cosine A. And you should be able to see that we can write this as sine A tan A. So now we've arrived at the right hand side. The left hand side, we started with the left hand side here, clearing the brackets, we have arrived at the right hand side. So this is a valid proof of this identity. Thanks for watching. I'm Alistair. Bye.